Most people move through the world assuming that everyone around them experiences it roughly the same way. Same colors, same sounds, same sensations. They are wrong. And the gap between what most humans perceive and what a small number of people experience is far wider than almost anyone realizes. Somewhere in the world right now, there is a woman who can see colors you cannot name, because they don't exist in your visual system. There are people for whom music produces an involuntary cascade of colors and shapes, as reliable and automatic as breathing. And there are people who have never felt physical pain in their entire lives, not because they are numb, but because a single mutation in a single gene rewired the way their nervous system processes the world. These are not metaphors. These are documented, verified, biological realities. And the people who live inside them are, in the most literal sense, experiencing a different version of the same physical world you're in right now. The question is not whether these people exist, it's what they reveal about the rest of us. I started looking into this, expecting a list of curiosities. What I found instead was a set of windows, each one opening onto a different version of human perception, and each one asking the same uncomfortable question: how much of what you call reality is just the particular hardware you were born with? So I went deeper. You see in 3 colors. More precisely, your retinas contain 3 types of cone cells, each sensitive to a different range of wavelengths, roughly corresponding to red, green, and blue. Your brain combines signals from these 3 channels to produce everything you can see, the entire visible spectrum, every sunset, every painting, every face. Most people assume this is complete. It isn't. In 2010, neuroscientist Gabriele Jordan at Newcastle University confirmed the existence of a woman she refers to in the scientific literature only as CD, a 29. After 2 decades of searching, Jordan had found what she was looking for: a functional tetrachromat, a human being with 4 types of cone cells instead of 3. The genetic precondition for tetrachromacy exists in an estimated 12% of women. It requires inheriting 2 slightly different versions of one of the X-linked cone genes, one from a colorblind father or son, one from a normal-sighted parent. The result is a 4th cone type, sensitive to wavelengths that sit in a range invisible to everyone else's visual system. But carrying the gene and using it are not the same thing. Jordan spent years testing candidates who had the genetic prerequisite. Most of their brains simply ignored the extra signal, folding it into the existing 3 channels as if it weren't there. CDA 29 was the first confirmed case in which the 4th cone was genuinely functional, wired into the brain as a separate channel of color information. What does she see? The honest answer is that no one fully knows, because there is no shared reference point. She consistently identifies color distinctions that are invisible to trichromats, differences that look identical to anyone else. The estimate from ophthalmologist Jay Knights at the University of Washington is that a functional tetrachromat may perceive up to 100 million distinct colors, compared to roughly 1 million for the rest of us. She's been living in a richer visual world than almost anyone around her. She had no way to know. Now consider a different kind of difference. For most people, the senses are separate channels. Sound is sound, color is color. A middle C on the piano is a pitch and nothing else. For roughly 4% of the population, this isn't quite true. Synesthesia is the automatic, involuntary, consistent triggering of one sensory experience by another. In the most common form, grapheme-color synesthesia, letters and numbers carry colors. The number 7 is always yellow. The letter A is always red, not as a feeling or a metaphor, visually, automatically, every single time. In sound-color synesthesia, music produces colors and shapes. The composer Olivier Messiaen saw specific colors when he heard specific chords, a phenomenon he built into his compositions deliberately, trying to translate his visual experience into sound that others might approach from the outside. The musician Billy Joel has described it. So has Pharrell Williams. What they're describing is not imagination. It is an involuntary perceptual event, as automatic and unchosen as flinching. Here's the strange part. The neurologist Richard Sidgwick, who spent decades studying synesthesia, described it as revealing something about how all brains work, not just the unusual ones. The sensory channels that synesthetes experience as crossed are, in most brains, crossed too. The difference is that in a typical brain, the signals are suppressed before they reach consciousness. In a synesthete's brain, they aren't. What synesthetes experience as unusual is, in some sense, what everyone's brain is doing. They just have a cleaner view of the machinery. Now set the science aside for a moment. Ashlyn Blocker was born in 2004 in Patterson, Georgia, a rural town of about 800 people. As an infant, she didn't cry during teething. At 8 months, her parents took her to the doctor for a bloodshot, swollen eye. The doctor put drops in to stain the surface and check for damage. Ashlyn smiled in her mother's lap while the dye revealed a massive scratch across her cornea. She felt nothing. As a toddler, she burned her hand on the motor of a running pressure washer and showed no sign of distress. Her parents initially assumed she had an unusually high pain tolerance. She had none at all. Ashlyn has congenital insensitivity to pain, caused by a loss-of-function mutation in the SCN9A gene, the gene that encodes a sodium channel called NaV1.7, essential for transmitting pain signals from the body to the brain. Without it, the signal never arrives. She can feel pressure and temperature. She knows when she's been touched, but pain, as the rest of the world experiences it, does not exist for her. Most people hear this and think, lucky. The medical reality is different. Pain is one of the body's most essential protective systems. Without it, injuries compound unnoticed. Ashlyn has broken bones she didn't know were broken. She has to inspect her body visually for damage that other people feel. Her parents spent her early childhood following her at close range, watching for injuries she would never report. She learned to protect herself intellectually rather than instinctively, building habits and routines that replaced what the nervous system was supposed to do automatically. Her condition is extraordinarily rare. By the time University of Florida researchers identified her specific SCN9A mutation in 2009, fewer than 50 cases of this form had been confirmed worldwide. The SCN9A gene is now one of the most intensely studied targets in pain medicine. Pharmaceutical companies have been working on NaV1.7 blockers as potential painkillers for years. Her condition has become one of the most important models for an entire area of pain research. She is also, by all accounts, a thoughtful and completely ordinary young woman who happens to live in a body with different rules. Each of these conditions, tetrachromacy, synesthesia, congenital insensitivity to pain, could be read as a glitch, a deviation from the human standard. But the more you look at them, the less they resemble errors. Tetrachromacy reveals that the human visual system is not maximally efficient, it's merely sufficient. The hardware for perceiving far more color exists in a significant fraction of the population. Most brains simply don't use it. The question this raises is not why some people see differently, it's why the standard settled where it did. Synesthesia reveals that sensory separation in a typical brain is an active process, something the brain does, not something it simply has. Evidence suggests the crossed signals are present in most brains. The filtering is what differs, and what makes most people's experience of the world feel seamlessly separated. And congenital insensitivity to pain reveals with uncomfortable precision what pain actually is. Not the injury itself, but a signal your nervous system generates in response to damage. Remove the signal and the damage continues unannounced. The pain was never the problem. The signal was. CDA29 still lives somewhere in England, seeing colors that have no names in any language because no one else can see them to name them. Ashlyn Blocker still does a visual check of her body before bed. And somewhere out there is a person hearing music right now as a field of shifting light. Automatic, involuntary, as natural to them as silence is to everyone else. These people did not choose their perceptions, neither did you. The difference is that their hardware makes the gap visible. The world you experience as reality is the world your particular nervous system produces. It is not the only version. If 3 tiny biological differences can create entirely different versions of reality, how many more exist that we've simply never discovered?